Swayam Prabha. Digital India. Educated India.
Hello everyone. In the previous class, we discussed that how we can determine the ultimate bearing capacity of a strip footing resting on the rock mass using the Bell's approach. I explained you that approach with the help of the assumption that the rock mass is following the Moore Coulomb failure criterion and also when it was following the Hook and Brown criterion. So, today we will take up few other approaches in order to obtain the bearing capacity of the shallow foundations. So, before we start working on the determination of the bearing capacity of the foundation, first let us try to see that what all are the methods which are available for the determination of the safe bearing pressure on the rock and what exactly are their applicability in different situations. So, take a look at this slide. This table has been taken from the relevant code, that is IS 12070, and the first column says about the basics of the design method and the next one talks about the rock quality. So, the first one deals with that rock mass classification. So, in case you have good rock with wide or very wide spacing of the discontinuities, then you can find out the safe bearing pressure on rock using the approach which is based upon rock mass classification. When I say wide or very wide spacing of the discontinuity, that means that as far as wide discontinuity is concerned, it may vary between 1 meter to 3 meter, and in case if the spacing of the discontinuities they are more than 3 meter, they fall under the category of very wide. The next design method can be the core strength or on the basis of UCS. So, when you have the rock mass with closed discontinuities at moderately close spacing, that means when the spacing is lying between 0.3 meter to 1 meter, in that case if you obtain the safe bearing pressure from the core strength or from the UCS of the rock, then it is quite reliable as far as the determination of safe bearing pressure is concerned. The third category, which belongs to the rocks of low to very high strength, that is less than 500 kg per square centimeter, rock mass with discontinuities at close or very close spacing. When I say close, means it is lying between 5 to 30 centimeter, and for very close the spacing is less than 5 centimeter. In case of the fragmented or weathered rock, then we can find out the safe bearing pressure using the results of pressure meter test. This test right now is beyond the scope of this particular course, but for the sake of completeness I have put it here for your information only. The third category involves the rocks of very low strength, which is less than 250 kg per square centimeter, and this also include the rock mass with discontinuities at very close spacing. It can be fragmented or the weathered rock. So, if such type of rock mass is present at the site, then we can carry out the plate load test, and from there we can analyze the data of this test and find out the safe bearing pressure on the rock. Today we will try to understand how we can obtain the safe bearing pressure on the basis of rock mass classification and the core strength. So, from the classification approaches, it is really not possible to get universally applicable values of the safe bearing pressure, because there are many factors which influence the safe bearing pressure, and many a times the whole phenomena is controlled by the settlement criteria and not the shear criteria. Nevertheless, these approaches are often useful to estimate the safe bearing pressure for preliminary design on the basis of classification, but we need to be careful that whatever are the values of safe bearing pressure that we get from the classification approaches, these should be checked or treated with caution for the final design. As far as the preliminary design is concerned, one can use these values, but for the final design one needs to be extremely careful. The table here shows various material and the corresponding value of net safe bearing pressure, which is represented as QNS, and these values have been given in ton per meter square. So, in case if you have massive crystalline bedrock including granites, diorite, gneiss or the trap rock, in such case your net safe bearing pressure can be taken as 1000 tonnes per meter square. The second case deals with the foliated rocks such as schist or slate in the sound condition, and the corresponding value of net safe bearing pressure can be taken as 400 ton per meter square. In case of the bedded limestone in the sound condition, again the value can be taken as 400 tonnes per meter square. For the sedimentary rocks including hard shales and sandstones, this value reduced to 250 ton per meter square. When at the site you have soft or broken bedrock excluding shale and the soft limestone, then in that case the net safe bearing pressure, see, it further reduces and it can be taken as 100 ton per meter squares. However, in case of the soft shale, this value gets really very low and can be taken as 40 ton per meter square. Let us take a look that how we can determine the safe bearing pressure from the rock mass rating. The earlier table gave you the overall idea that in case if you have some typical type of rocks which are present in the field, then some values can be assigned as the net safe bearing pressure. Now, this is what is based upon the rock mass rating. You already know how to determine the rock mass rating. So, from here we get net allowable pressure, and the value that we get ensures that the settlement of raft foundation, which is up to 6 meter thickness, to be less than 12 mm. That means this is what is a permissible settlement which is considered in order to determine the safe bearing pressure from the rock mass rating. So this table gives you the idea about the value of RMR and the corresponding value of allowable bearing pressure QNS. So in case if you have very good type of rock, its corresponding RMR would be 100 to 81, and the value of the safe bearing pressure can be taken as 600 to 448. And likewise, in case if you have good or fair, poor or very poor kind of rock mass quality based upon their respective values of the rock mass rating, you can pick the appropriate value of this QNS in ton per meter square from the last row of this table. So this is how you can obtain the safe bearing pressures from the rock mass rating. One needs to keep few things in mind while making use of this approach in order to get the safe bearing pressure of the footings. Let us see what are those. So whatever are the RMR that we get from the field, and if we want to use in order to get the safe bearing pressure as it was given in the table in the earlier slide, that RMR value should be average within the depth below the foundation level, which is equal to the width of foundation, provided RMR is fairly uniform within the depth. Let us say that this is your footing and its width is say B. So say it has been placed here. So from this level we go up to the depth equal to this width of the footing, and then we try to get that whatever is the value of average RMR in this zone, we try to get that value of RMR for use in the table and get these safe bearing pressures. The one condition which is there, the one assumption which is there, that RMR should be fairly uniform within this depth. If too much of non-uniformity is there, then that may not give you the proper value of the safe bearing pressure. Now in case if the upper part of the rock within a depth of about 1/4 of the width of the foundation, if this is of the lower quality, then the value of this part should be used or the inferior rock should be removed. Let us try to understand with the help of a figure again. So if this is the footing, let us say, and it is being placed say at some depth, this has a width of B. So what does this mean is that let us say below this up to 1/4 of the width of the foundation, if this part is of inferior quality, then either you use the RMR which is relevant in this zone, or what you do is you remove this portion and then you place the footing on the better quality of the rock. So these are some of the things one needs to keep in mind when you use RMR to obtain the safe bearing pressures. Since these values which are there in the table as discussed, these are based upon the limiting settlement, they should not be increased if the foundation is embedded into the rock. So whether it is a surface footing, that is like this, and in case if there is the embedment, which is there in most of the cases. You will never have the surface footing. So here the embedment depth is say Z. So in such case, whatever is the value that you obtain, that you should not increase to account for this overburden. Now this was all about the safe bearing pressure determination from the rock mass rating. Let us take up that how we can find out safe bearing pressure from the uniaxial compressive strength test data. You know that when the rock is sound, the strength of the foundation rock is generally much more than what we need for the design. Provided the walls of the discontinuities are closed and these discontinuities are favorably oriented with respect to the applied forces. Now when I say whether these are favorably oriented or unfavorably oriented, I explained you these situation with the help of these figures. So take a look once again and then you will be able to appreciate that how the orientation of the discontinuities can be very favorable, favorable, fair, unfavorable or very unfavorable as far as the placement of the footing on such type of rock masses is concerned. So the investigation should be concentrated on the identification and mapping of all the discontinuities in the rock mass within the zone of influence of the foundation, including the determination of the aperture or the opening of discontinuities. Now how to determine that what is going to be the zone of influence of the foundation? You have seen that depending upon the orientation of the discontinuities, there is going to be the extent of the pressure bulb in different cases. So till the depth that the pressure bulb gets extended below the footing, that is what we call as a zone of influence. So it is not only the zone of influence that we must know, but we should also know about the aperture or the opening of the discontinuities. An evaluation of the mechanical properties of these discontinuities, frictional resistance, compressibility and strength of the infilling material, if any. Let us say if the joints are open and if there is any infilling material in between these, all these factors they influence the safe bearing pressure and therefore these should be evaluated properly. Then the identification and evaluation of the strength of the rock material according to the relevant Indian Standard Code, that also should be done. In case of the rock mass with favorable characteristic, that is when the rock mass is parallel to the base of the foundation, that we saw that it is the most favorable condition, the load which is applied will have no tangential component and the rock mass, if it has no open discontinuities, then the safe bearing pressure can be estimated from this expression, which is equal to Qs, that is Qc into Nj, where this Qs is the safe bearing pressure and here it is the gross, not the net. Then Qc is the average UCS of the rock course. When I say rock course means I am talking about the intact rock in the zone of influence below the foundation. Coming to the term Nj, this Nj is, so we have Qs is equal to Qc into Nj. So, this Nj here is the empirical coefficient which depends on spacing of the discontinuities and is given as Nj is equal to 3 plus S upon Bf divided by 10 into square root of 1 plus 300 times delta upon S, where this delta is the thickness of discontinuities in centimeter, S is the spacing of discontinuities, again it is in centimeter, Bf is the footing width and this is also represented in the centimeter. Now, one needs to keep in mind that here what we are getting is the gross value of the safe bearing pressure. So, here this particular equation uses a factor of safety of 3. Please remember this, because when you find out the safe bearing pressure is the ultimate bearing pressure that divided by the factor of safety. So, basically this equation uses a factor of safety of 3. Now, based upon the spacing of the discontinuities, you can assign the value of Nj if you do not want to evaluate it from that expression. So, this table has been given for your guidance, that in case if you have the spacing of the discontinuities as 300 centimeter, then Nj can be taken as 0.4. If you have 100 to 300, it is 0.25, and in case of the spacing of discontinuities lying between 30 to 100 centimeter, this Nj is 0.1. This relationship is valid for a rock mass with a spacing of discontinuities greater than 0.3 meter aperture or the opening of the discontinuities and less than 10 millimeter, and in case if you have the joints filled with soil or rock debris, in that case this becomes 15 millimeter, and the foundation width which is greater than 0.3 meter. In case if you have the foundation width less than this value of 0.3 meter, then that relationship will not be valid, it cannot be used. So, this is what that I wanted to discuss with you as far as the determination of the safe bearing pressure is concerned from the classification approaches and from the core strength or the uniaxial compressive strength of the intact rock. So, in the next class we will take up the process for the determination of the safe bearing pressure from the plate load test, and then we will see that what are some of the special problems or the treatment that should be given to the foundation. Thank you very much.